Okay, so this video is going to look at the second of our calculations, which is this one, n equals c times v over 1,000. So the first thing we'll do is we'll just look at what each of these means. So n here, this is our number of moles. Remember from that first video, number of moles is the number of particles, and its units are moles. C over here is concentration, and its units are moles per decimeters cubed, or moles divided by decimeters cubed. It can be written a variety of ways. Either moles and then divided by decimeters cubed, or if you don't put the divide sign in, you might see it with -3 written here, which just means the same thing, moles divided by decimeters to the -3. You may even just see it as a capital M. This is our volume. Now typically, we want it to be in decimeters cubed. This equation here is actually for it when it's in centimeters cubed. And to convert from centimeters cubed to decimeters cubed, we divide by 1,000, which is where this number comes from here. A centimeter cubed, easiest way to look at it, centimeter cubed is a milliliter, decimeter cubed is a litre. Is that a similar one? So we've got our number of particles, we have our concentration, we have our volume. So let's have a look at our first question. How many moles in 250 centimeters cubed of a 0.2 moles per decimeter cubed solution? So the first step here is to write down what do we know. And I know the volume is 250. I know concentration is 0.2. And it's asking me to work out the number of moles. So we put this into our equation. N equals 0.2 times 250. Now, these units here are centimeters cubed, so I need to divide by 1,000 to get it into the right units. So that, well, into decimeters cubed, to convert this into decimeters cubed. So I'm going to put n equals 0.2 times 250 divided by 1,000. If you put that into a calculator, you should get 0.05 moles. And that would be how many moles there would be in this solution. If we just have a look at what that means, we'll look at the concentration here. And if I took 1 decimeter cubed of this solution, so this is a 1 decimeter cubed solution, this concentration means that if I was to add up all the particles in that 1 decimeter cubed, I would have 0.2 moles dissolved in that 1 decimeter cubed. But I don't have a 1 decimeter cubed, I have a 250 centimeter cubed solution, which is exactly 1/4. So I've got my 250 centimeter cubed solution, it's 1/4 of this. So in 1/4 of this, we're going to get 1/4 of the particles. So in here, we've got 0.05 moles. These concentrations are the same, but the number of moles are different because the volume's changed, and they're all in relation to each other. So the second type of question that comes up is this. This time we're going to have the concentration to work out. So if I put down everything I know the number of moles, it's 0.1. I could even know the MR, which depending on your periodic table, it'll either come out as 40 or 40.1, 23.1 for sodium, 16 for oxygen, 1 for hydrogen, and then we have volume, which is 200. So if I want to work out the concentration, I can see that the MR is really not going to be too much use to me, because the only equation we've seen for concentration doesn't have MR in it, just has N and V. So if we go to this, what we've seen earlier, we now need to rearrange this to make C our subject. So the first thing I'm going to do is times both sides by 1,000. So I've got N times 1,000 here, and if I times 1,000 on the right hand side, it's going to cancel this out. So N times 1,000 goes to equals C times V. Now I need to divide by 1,000, sorry, in this equation, because I'm in centimetres cubed. Now I've got N times 1,000, C times V. I want C as the subject. So I can divide both sides by V. Puts a V there, so divided by V equal to C, because that V gets cancelled out if I divide by V and times a V, just cancels each other out. So that is now my new equation. C equals N times 1,000 over V, if my volume I have is in centimetres cubed. So that is then 0.1 times 1,000 over 200, which gives me a concentration, put it down here, of 0.5 moles per decimetre cubed. If I have 0.1 times 1,000 gives me 100, divided by 200 is about half essentially, so 0.5 moles per decimetre cubed. The final one, and it doesn't come up very often, is if you had a volume. And now this doesn't come up very often because it's very easy just to measure the amount of volume. We never really need to calculate it. We just put it into a measuring cylinder and work out the volume. But we'll go through it anyway, because rearranging the formulas a great skill to be able to do. So here I have my number of moles. I know N, 0.25. I've also got concentration, 1.5. And the volume is what I want to find out. So I'm going to do the same thing again. Now, if I want to find out the volume in decimetres cubed, I wouldn't include the 1,000. So I'm quite happy to work out it in decimetres cubed, just for consistency, because I have in the other two. I'm going to put the 1,000 in there anyway. This time, if I've got the 1,000 in there, then I'm going to work out the volume in centimetres cubed. So my final number that I work out here, units, will be centimetres cubed. Now I need to make V the subject, so again I'm going to times by 1,000, so I'll have N times by 1,000 equals C times V. So if I times both sides by 1,000, that gets crossed out, the left hand side gets times by 1,000, and I'm going to divide both sides by C to cancel out this C here. So volume will equal N times 1,000 divided by C. So 0.25 times 1,000 divided by 1.5. This is where I wish I had a calculator. 0.25 is going to be 250 over 1.5. Oh. I don't have a calculator, so I'm going to do it old school. Into, I can't even do it old school now. There we go. So the volume is 166.6 recurring centimetres cubed. I would check that with your calculator. There's a very high possibility I've done that maths wrong, because I'm a chemistry teacher, because I wasn't good enough at maths. And that is the calculation, N equals C times V over 1,000. We can rearrange it. I'll include at the bottom, as usual, there'll be some questions for you to try and answer.